Good morning. Happy E-Day. Here we go. We're going to do topic 6.3 today. And it's all about proportions. We did proportions in triangles. Now we're going to do proportions with parallel lines. We're going to do proportions that don't even involve triangles at all, eventually. We're going to do something called a mid-segment of a triangle, and then we'll finish it off with some word problems. So let's get started. Triangle proportionality theorem. A line is parallel to one side of a triangle and intersects the other two sides if and only if it divides the side into two segments of proportional lengths. So we know that parallel, like anytime you see parallel, you're looking for angles that are congruent. So like these two angles are congruent because they're called corresponding. You got the Z thing, remember the Z thing going on? Those two angles are congruent because they are alternate interior. And now when you see parallel, you also get proportional parts. So let me explain. If you see this shape down here with some parallel lines in it, it separates these into proportions. So this line and this line is related in the same way that this line and this line is related. So as this is quite a bit shorter than this will also be quite a bit shorter than this. It will be proportional. If this is 4 and this is 2, so see a double situation going on there, then this might be 6 and this might be 3. All right, so that's how this situation works. There's all sorts of proportions, and you could say AB is to BC as AE is to ED. And there are other proportions that you could write in here, just as long as you're consistent. You could say 4 is to 6 in the same way that 2 is to 3. You could say 2 is to 4 and 4 is to 2 in the same way that 6 is to 3. You just can't go like, you can't say 2 is to 6. You can say 2 is to 4 because they're related because they're on this sort of side together. You could say 2 is to 3 because they're related because they're like the left side, but 2 is not really related to 6 at all, and 4 is not really related to 3. All right, so here's another question. If PS equals 6 and SR equals 2, now we see, what do we see? We see a triple relationship. This is triple the size of this. And PT is 9, so just do the triple relationship. This must be 3, okay? That's how that ends up working. Because of the parallel, you can do that. Over here, a little bit more words involved. If EH is 3 and HF is 9, I mean, that's a triple relationship right there. Again, 3 is a third of 9. And DG is 1/3 of GF. Now, even though it's not giving you numbers, it's telling you the relationship. And you could do that. You could say that, let's say that this is X. This is a third of X, like that. That's the same relationship. 3 is a third of 9. This is a third of X. So this is a good relationship proportionally. And therefore it says determine if the lines are parallel. Because we see the relationship, 3 is a third of 9, this is a third of X. These must be parallel. So it works both ways. If and only if is a two-way situation. If you have parallel, then you have proportions. And if you see proportions, then you have parallel. So 2 questions from this will be, solve for X of a situation. Moose. You guys want to see my puppy? Come here, Moose. I gotta let Moose out. Hey, Moose. Hey, buddy. I gotta go feed my dog real quick, or else he's gonna keep whining. Okay, just give me 1 minute. Be right back. Okay, I'm back. Okay, so like I was saying, two questions that I could ask. I could say, given the lines are parallel, I could have you solve for any of these lengths, or I could say, look at the lengths and determine if the lines are parallel. So that's that. Done with that theorem. Here we go. On to the next thing, the midsegment of a triangle. We've done midsegment before, if you remember. We did midsegment of a trapezoid. You go in the middle, and if you remember, the midsegment of a trapezoid was the average of the two bases. So if this was 10 and this was 20, then this length would be 15. Also, these were parallel, if you remember. Okay. Now, the midsegment of a triangle. The midsegment triangle is a segment with endpoints that are midpoints of two sides of a triangle. Every triangle has 3 midsegments. So over here, here's a triangle. This is a midsegment, connects midpoints. This is a midsegment, it connects midpoints, and this is a midsegment. It's connecting midpoints. So as you can see, there are 3 midsegments of a triangle connecting midpoints. Should label my diagram like this. There we go. And what this ends up doing is it ends up splitting this triangle into 4 congruent triangles. These are all the same now, technically, if my diagram is perfect. These would all be the same triangle, just kind of flipped around a little bit. And with that, there's a bunch of angles now that are the same. There's all kinds of stuff that's going on here. So here's what's going on. A midsegment of a triangle is parallel. All right, so just like up here, these are all parallel. Over here, this side right here will be parallel to this side right here. We have parallel lines going right here and right here. We have parallel lines. Let's see here, to one side of the triangle, and it is remember this was the average, so if this was 10 and 20, this was in the middle. So think of this as, if this is 0 and this is 20, then this length would be 10. It's going to be half. Think about that. It's almost the same as a trapezoid. And it is half of the side length. So over here, if I get a midsegment like what I have here, okay, a couple things. We can see that FG is parallel to JK. FG is parallel to JK. And once again, JK will be equal to half of FG. All right, so if this is 2, if this is a length of 2, then this is a length of 1. It's half, okay? Let's draw a triangle and investigate. So we hit the triangle, we have negative 2, 4. Negative 2, 4 is right there. Negative 2, 4. We have 6, 2, which is right there. And we have 2, negative 2, which is right there. Okay, let's connect these dots. Let's do it in a meaningful way. So when I connect these dots, that's actually just a slope of 1. Up 1 over 1. I can see that, up 1 over 1. And there's the midpoint of that one right there. I can go like that. There's a midpoint. When I connect these dots, it looks like I'm going right through there. And so that's a midpoint right there. And when I connect these dots, it looks like I'm going through there. That's a midpoint right there. Okay, so now to get the midsegments, you connect the midpoints. And look at this. This is a nice graph. This length, these are all the same lengths. This length, and this length are all the same. Down 1 over 4, down 1 over 4, down 1 over 4. So they have the same slopes, and they're the same length. And same goes for here. Look at this slope This is up 1 over 1, up 1 over 1. This slope is the same as this slope. So those are parallel. And then lastly, this right here is the same as this right here. All right, so there's all sorts of stuff going on. This and this are related. That's how you gotta work this out. And here's what you will see. You have to work a question out like this. So these are mid-segments, and I should say assume mid-segments. I should put that on there. All right, so let's check it out. We have BC is 18, so B to C. So a couple things. If this is 18, and this is a mid-segment, that means that this is 9, it means that this is 9, and it means that this is 9. All those are going to be the same. It's pretty straightforward. So let's see, can we, FE. FE is 9. We can put that for sure. All right, so we're kind of done with that, done with all of that stuff. We have that FED is 87. So FED is 87. All right, so now let's fill in all the angles that we can. So now I know that this is 87. Why is that 87? Because these lines are parallel. Those lines are parallel, and we have a Z. See the Z? So that must be 87. Furthermore, we have a linear pair right here, so these have to add up to 180. So that should be 93. Same thing over here with this Z. We have a Z here as well. So 87, 87, alternate interior angles, 93. And using a parallelogram, this is actually a parallelogram, and you can see the opposite angles are the same. This has to be 87 as well. So I'm filling in all of my angles. If you want, you can put a little degree symbol there so you don't get confused with the side lengths. All right. Also, I'm gonna get another colored pen here real quick because I got a lot going on in this picture now. All right, let's see here. Let's see, there, I got a blue. If ED is 5, if this is 5 right here, this line is related to these over here. So if that's 5, then this is 5, and this is 5. Okay, then the whole length would be 10. So that's how that works. Let's see here, AB, A to B would just be 5 plus 5 is 10. And AFE, that's this angle right here, is 87. So all kinds of stuff going on in this picture. You will definitely have to do this. This is happening. And it's always one of the most missed questions. But if you just sit down with it for 5 minutes and study it, it doesn't have to be. It doesn't have to be challenging. Look at the patterns. 5, 5, 5. 9, 9, 9. Parallel, parallel. All right, use some Z's to get these angles. There's a parallelogram right here. Look at the opposite angles. They're all the same. This all adds up to 360 because it's a quadrilateral in here. Now, what we can't do is we don't know what these are. These are still a mystery. I can't really figure these out. I do know that these two angles right here have to add up to 93 because these have to add up to 180, but I don't know how it's distributed. I don't know how the 93 is distributed. Just can't really tell. All right, so last thing really to go over before we just get to some word problems is proportional parts of parallel lines. You don't even need a triangle really for all this stuff to work. You just need parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut off transversals proportionally. All right, so what I mean is if you've got parallel lines in this situation, then this line and this line are proportional to this line and this line. So we can write all kinds of proportions. We could say AB. We could say AB is to BC as EF is to FG, like that. The blue is to red on the left as the blue is to red on the right. You could also go blue is to blue as red is to red. What you can't do is cross. You can't go like this is to that. Those aren't related at all. This is blue and on the left, so you could relate blue to blue, or you could relate left to left. This is red on the right, so you could relate right to right, or you could relate red to red. You can't relate this one to this one. You can't relate this one to this one. That's not how it works. Okay, over here, it says find at least 4 proportions. There's all kinds. All right, we could say 20 is to 12 in the same way that 25 is to 15. So for example, these both reduce. This reduces. This is 5 4s. This is 3 4s. This is 5 5s. This is 3 5s. So it works out. This is a 5 to 3 situation. You could do 20 is to 25 as 12 is to 15. That works, and that reduces as well. This is 4 5s, 5 5s, 4 3s, 5 3s. You can cross multiply to check it if you want. There's all kinds of proportions. There's more in here. Here's a problem. Find the ocean frontage of lot A. Here this is the ocean. We've got some lots of land. We got a driveway or a road. They tell you the frontage of the road. I want to know what's the ocean frontage of that. Because we've got parallel lines here, we can set up a proportion. We can say X is to 58, for example, in the same way that 60 is related to 42. Okay, as 42 is just a little bit less than 60, 58 will be a little bit less than X. So that's what I know for sure. Now here, I'm just gonna do that on my calculator. Let me grab my calculator real quick. One moment. Okay, we do the old calculator trick here to solve this proportion. You cross multiply what you can and then divide by the other number. And we get X is about 74.3 yards. There we go. That's all you gotta do. Okay, we have our challenge there. Show that to me if you can figure it out. I'll give you a 6 out of 5 on your homework. And to finish this off, we'll just do these last 3 questions. All right, so this is how this can translate into life. We use proportions all the time, whether you know it or not. Here's an example. Concrete is made mixing cement. Concrete is cement, sand, and stones. That's what it is. Cement, fun fact, cement is a limited resource on the planet. Eventually we will run out. Cement, sand, and stones using a ratio of 1 to 2 to 6. 1 part cement, 1 part sand, 1 part cement, 2 parts sand, 6 part stones, respectively. Someone who does not understand proportions, put 3 buckets of each into the mixer. So now we're at a 3 to 3 to 3 ratio, and I need a 1 to 2 to 6 ratio. So how do I fix it? Right now, this will not make cement. This will not make concrete. This is a bad ratio. I do not want a 1 to 1 to 1 ratio. I want a 1 to 2 to 6 ratio. So how do I fix it? You keep that as 3, and then let's see here. This is a 1 to 2, so this needs to be doubled. So we'll make that a 6, and this is a 1 to 6, so this needs to be times 6. This needs to be a 1 to 6 ratio, so we need to multiply this by 6. Okay, so how do I fix it? I need to take this and turn it into this. Come on, okay. So 3 to 3, we'll just don't add any more cement. We got to go up three parts of sand. Add 3 parts of sand, and we got to go from 3 to 18. Add 15 parts of stone. There we go. So now we fixed it. We had this was a mess. We're gonna fire this guy. We're gonna get a new guy that can do proportions correctly. So we want to turn this into this. Add 3 parts of that, add 15 parts of that, we're good to go. Look at this question. This is an interesting one, considering today. A snowstorm is predicted from 2 p.m. to 6 a.m. the following morning, and it's predicted to dump 18 inches of snow. However, my snowblower can only accommodate a maximum of 8 inches of snow. What is the latest that you should clear the driveway for the first time? Because if you don't get this math right, you're stuck. So, a snowstorm is predicted from 2 p.m. to 6 a.m. First of all, how long is that snowstorm? 2 p.m. to 6 a.m. Let's see here. That's 2 p.m. That's let's see here. That's 10 hours to get to midnight, plus another 6 hours to get to 6 p.m. So 10 plus 6, that's 16 hours. All right, 2 p.m. to 6 a.m. Following morning is predicted of 18 inches of snow. So what we have is 18 inches of snow in 16 hours. So we can set up a proportion, 18 inches in 16 hours. And what I need to know is how long before I get 8 inches of snow. Okay, so I can just set up a nice proportion and I can solve for x. And that's going to be in hours, so I have inches over hours. And over here, it's going to be inches over hours. So now I can plug this into my calculator. As long as you have your units lined up, you don't have to worry about the units when you're plugging in. So I'm going to cross multiply. I'm going to do 16 times 8, and I'm going to divide by 18. There we have it. And that leaves me with 7.11 hours. 7.11 hours. So now let's translate that back into time. So 7.1, does that mean 7 hours, 11 minutes? No, that doesn't mean 7 hours, 11 minutes. It means 7 hours plus 11% of an hour. Now what's 11% of an hour? You gotta multiply it by 60. That's about, I'm gonna call it 7 minutes. So I need 7 hours and 7 minutes. It's about 10%. It's almost 10% of an hour. Okay, so 7 hours, 7 minutes. Now let's translate that into time. It started at 2 p.m. So do 2 p.m. plus 7 hours. That would be 9. So we have 9:07 p.m. So I would say probably, I would just go out at probably 9 o'clock. Go out at 9 o'clock and do my driveway. Then I'd have to go out in the morning and do the driveway again. Okay. This question, number 9. This will be on your test, so pay attention. Have you ever wondered how, like, zoo people or animal activists, whatever, they'd be like, there's only 10,000 lions that exist in the wild anymore, or there's 5,000 elephants remaining in the world. How do they do that? How do they figure out? Do they count every elephant? Well, here's how they do it. They use tags. What I mean by tag is they collect some animals and they give them an earring, and then, or they give them a chip, and then they'll send them back out in the wild. And now we have these tagged animals out in the wild that we can monitor. So, but they look at proportions. To determine the number of deer in a forest, a ranger tags 280 deer and releases them. So now, in this forest, in this whole forest, there's 280 tagged deers. So there are 280 tagged for the entire forest in the total. Okay, there's 280 tags for the total forest. And now we're going to take a sample, and we're going to look at our sample. Later, in a total of 405 deer, So in 405 total, in my sample, we find that 45 of them are tagged. Okay, so now we're doing tagged over, and we're gonna solve for X right there. Total tags to total in the total forest to sample tag in the sample total, and this is how we can set this up. So as 45 is quite a bit smaller than 405, 280 is going to be quite a bit smaller than X. And now we just forget about that. We're just going to use our proportions. 280 times 405. Oops. 280 times 405 divided by 45 gives you that many deer in the forest. Deer in forest. Pretty cool. That's how we can count the number of deer in a forest without counting the number of deer in the forest. And that's all we need to do today. Have fun. Be safe.